Welcome to This Explainer. Okay, today we are pulling back the curtain on a hugely critical part of software development. It's a field that, honestly, usually only makes the news when it fails completely, catastrophically. We're talking about quality assurance. Let's dive right in and find out exactly what stands between fast-paced coding and a total system meltdown.
First, take a look at the sheer terrifying scale of this number, $440 million. Back in 2012, a single software bug was accidentally deployed into the live production environment of a trading firm called Knight Capital Group. That one single bug ended up costing the company $440 million. And honestly, the absolute kicker here, they lost all of that money in just 45 minutes. That is roughly $10 million evaporating every single minute, all because a piece of untested, broken code made its way out the door. This is the staggering, real-world reality of what happens when QA fails.
And the damage can scale up to affect entire economies. In 2015, a really simple software glitch in the Bloomberg terminal cascaded through their entire network. It totally halted the systems used by over 300,000 traders worldwide. It was so severe and so paralyzing to the financial markets that the UK government actually had to postpone a massive £3 billion debt sale. In our hyper-connected digital economy, a single bug doesn't just impact one company anymore. It spreads like wildfire across global systems in seconds.
But the absolutely crucial point here is that testing isn't just about business metrics, right? It's not just about protecting revenue or keeping stock prices up. In many sectors, critical software failures can tragically cost lives. Take the China Airlines Airbus A300 crash from 1994. 264 lives were lost, and investigators fundamentally linked the tragedy to a software failure in the aircraft systems. It's an incredibly sobering reminder that for safety-critical systems, like aviation, medical devices, or the software in your car, rigorous QA is literally a matter of life and death. So, how do we actually prevent these kinds of disasters? Well, we kind of have to look at the foundational rules. The official ANSI/IEE standard defines software testing as the process of evaluating a software product to find whether it meets required conditions and is defect-free. Basically, it's a highly structured, rigorous system to check if the product actually does what we designed it to do. And honestly, just as importantly, making sure that it doesn't do what we absolutely don't want it to do.
Now, this brings up a super common point of confusion in the tech world. People will constantly use quality assurance and quality control interchangeably, but they are actually two totally distinct disciplines. Quality assurance focuses on the process. It's all about setting up the right systems, the right rules to prevent bugs from ever being written in the first place. Quality control, on the flip side, evaluates the actual products to find the bugs before they ship to the customer. So one is proactive, the other is reactive. And for a healthy software lifecycle, you absolutely need both.
So why does all this matter? Why do companies pour millions into building out these QA teams? Simply put, the return on investment is absolutely undeniable. Catching a bug early in the design phase is exponentially cheaper than trying to issue a massive patch after it's been downloaded by 1 million users. It also locks down your data against critical security vulnerabilities, ensures top-tier product quality, and keeps your customers happy. I mean, think about it. Nobody stays loyal to an app that constantly crashes on them, right?
Okay, so how is this vital work actually done day to day? We generally divide software testing into two main approaches. First up, manual testing. This is where actual human beings sit down and creatively, sometimes chaotically, explore the software. While it can be prone to human error, it is completely vital for understanding the true user experience and catching those weird visual bugs. Then we have automated testing. These are scripts executed by machines using frameworks like Selenium or Cypress. They are insanely fast, robust, and scalable, which is perfect for continuously checking that old bugs haven't crept back in.
And this testing builds systematically. It's like a puzzle, progressing in very clear steps. We start at the absolute bottom with unit testing. This is where developers check tiny individual blocks of code in total isolation. Once those work perfectly, we move up to step 2, integration testing, making sure those separate mocks actually play nicely together. Then comes step 3, system testing, where the entire compiled app is tested as one big whole. And finally, user acceptance testing, or UAT. That's where real end users get their hands on the software to validate that it actually solves their real-world problems. We can also neatly slice this complex world of testing into two easy-to-understand categories. First, functional testing. This focuses strictly on the business requirements. It answers the simple question, does clicking the submit button actually save the data? Common examples here are your smoke tests or regression tests. But then we have non-functional testing, which is all about performance and reliability. It doesn't care what the system does, it cares how well it does it. Will the site crash if 100,000 people log in right now? Tools like JMeter and Postman are absolute game changers here.
Right, so with all these different layers, these specialized tools, and honestly, incredibly high stakes, you kind of have to wonder who is actually responsible for running the show? Who is orchestrating this massive defensive effort every single day?
Let's break down the real unsung heroes of the tech industry, the QA team. First, you have the QA engineer. They're basically detectives. They focus on manual and exploratory testing, diving deep into the app for hours, just hunting for those weird edge cases. Next is the automation engineer. And what's really fascinating about them is they're essentially developers whose entire job is to write code that tests the main code. Pretty cool, right? And finally, the QA lead. This is the general. They orchestrate the entire strategy and make sure testing is perfectly woven into the whole software development lifecycle.
Now, if you're a product manager or a founder watching this, you might be looking at all these layers and thinking, doesn't all this thorough testing create a massive bottleneck? Doesn't this just completely slow down the release cycle in an industry where speed is literally everything?
Well, actually, modern software teams have completely hacked this problem through a practice called shift-left testing. Imagine your development timeline reading from left to right, from the planning stage all the way over to launch. Shift left means taking QA from the very end of the line and integrating it entirely into the beginning, shifting it to the left. By getting testers involved during the initial design phase, teams catch defects when they are incredibly easy and cheap to fix. It totally eliminates that dreaded bottleneck at the end of the line.
Ultimately, the mindset of a modern QA tester is completely counterintuitive to how we normally use our devices. A modern QA suite doesn't just verify that the app works on a happy path, where the user perfectly types in their password and clicks the right button. No, it actively attempts to break the application. A great tester will throw a massive amount of bad data at a form, click buttons way too fast, and just generally cause absolute chaos. They want to find your app's breaking point in the lab long before your users find it out in the real world.
It all boils down to this core philosophy. QA teams do not slow down development. They make sure what ships actually works. They are your absolute last line of defense. Without a rigorous QA process, your team isn't actually moving fast. They are just rushing blindly toward a potential disaster. Solid testing brings the confidence you need to truly innovate.
So, I'm going to leave you with this. Look closely at your own projects, whether it's a tiny startup app or a massive enterprise system. Are you entirely confident your code works under real pressure? Or, by cutting corners on QA, are you just quietly building the next $440 million bug? Something to think about. If you found this explainer helpful, please drop a comment below with your own QA nightmare stories, and don't forget to subscribe for more deep dives. Catch you in the next one.